Hey, greetings. I'm David, and I'm here with,
Ashley.
and we're going to do a number theory video here. So we're finished with our topology series and starting a number theory series now. Okay. So we're going to tell a little story. Okay. You ever like stories? You like history? Okay,
No,
good.
not.
Not really. You like math? Okay. Well, this is like a little bit of math history here. Okay, and it's interesting. For example, did you know that back in Germany in the 1700s, in the little towns, only the little boys went to school? What do you think of that? Is it fair?
No.
Not fair. Hey, well, they did. The boys went to school and the girls stayed home. So it's not fair, but it's what it was back then, okay? So they had a school and they had a teacher in this little town. And the way it worked is all the kids had their desks, okay? And the teacher, his desk was up on a platform. He set up above the students. And to be a teacher, you had to be very strict. So he had a whip. Okay, he could spank the kids with his whip, okay? And he could threaten, and he was very strict teacher. Well, what would happen is these kids would come to school in the morning, they'd go home at lunch, and then after lunch come back for the afternoon. One day it was a real warm day, okay? Very warm day. The kids went home for lunch, and the teacher ate a real big meal. He just ate a lot, okay? Do you know what happens when you eat a whole bunch of food and it's a nice warm day? What happens, do you know?
You throw up.
You might throw up, but maybe not that much. But for me, if it's a warm day and I eat a lot of food, I start getting tired. I want a nap, you know? After the meal, you want a nap. So this teacher ate a lot of food, and all of a sudden he says, I need a nap. He wants to sleep. But guess what? A bunch of these little 11-year-old boys are coming back. What's he going to do with them? They didn't have paper. The paper might have existed, and this was about 1788 this happened, but the kids didn't have paper in school. They had a little slate, maybe the size of a sheet of paper, like a little slate chalkboard, and they wrote on it with chalk, okay? And so the teacher had a plan. He said to these kids, sit down, be on your best behavior or you'll get in trouble, okay? And he said, here's your assignment for the afternoon. He said, I want you to add up all of the numbers from 1 to 100. Could you do that? Add all the numbers from 1 to 100? No calculator. You could. I'm sure you could, couldn't you, if you had to?
You could.
You could, but it would take what?
A long time.
A long time. Well, that's the idea, because guess what? The teacher thinks he's going to get these kids working, you know, and then he's going to put a book up in front of him, and while they're working, he's going to take a nap. Okay, that's his plan. So no, he says add all the numbers from 1 to 100. And he hits his whip. Get to work or you're going to get in trouble. And they get out their slates, and he gets the book up, and he's getting ready. Okay? So what do you think happens next? Well, he doesn't even have one eye closed. Okay, he's ready for his nap. He's not even got his eye closed yet. This little boy walks up with the slate and says, I have the answer. Well, the tradition the teacher had when he used to give problems is each person would get their answer and they put their slate upside down. And the next one put their slate on top, and the next one put the slate on top. And when they got them all done, he would take the slate, turn them over, and he'd start going through them. Who's the first one who was able to get the right answer, okay? So this little boy says, I'm all done, and put my slate down. Teacher's like, there's no way you can get that problem in 5 minutes. So he told this kid, he said, the little boy's name was Carl. He says, Carl, sit back down and do it right. You know you don't have the answer. You couldn't do it that fast. Carl says, no, I'm putting my slate down. I have the answer. The teacher said, boy, if you have the wrong answer, we're going out and you're going to get a whipping. Now get serious, get back and do the problem. And you know what Carl said? I'm leaving my slate, I'm done. Okay? So he says he has the right answer on the slate. Okay? Guess what the problem is for the teacher? You know what it is? He doesn't know what the answer is. He hasn't done it himself. The teacher has no idea what the right answer is. So he doesn't even know what the right answer is. And here's this kid claiming to have the right answer. And here's, you know what the worst part is for the teacher? Now he's not going to get his nap. Poor thing, hey? No nap? Don't you feel sorry for him? I mean, the teacher wants a nap, and now this little rascal's going to spoil his nap. So the teacher didn't know what to do. He's like, what am I going to do? Of course, he's not going to tell the kid he doesn't know the answer. No, you don't tell the kid that. So he decides to say to the little boy, okay, show me how you got your answer. Okay? Show me how you got your answer. And here's what the little boy did, okay? He said, imagine if I wrote all the numbers down like this, okay? 1 plus 2 plus 3, and then imagine all the numbers in between, and we're going to go up to plus 99 plus 100. So he writes them down like that, okay? He said, now you know it takes too long to add them up once, so to save time, I'm going to do it twice. I'm going to do it twice because it takes too long to do it once. What do you think of that? Crazy.
I don't get it.
No, the teacher didn't either. The teacher's like, what's this kid doing? Is he playing with my mind? Because the kid was real smart, but the kid was also a real little mischievous, little troublesome kid sometimes. So the teacher thinks this kid's just being a fool. But the kid says, but when I do this the second time, I would write them like this. 100 underneath, plus 99, plus 98, and so on, all the way down to 1. See, he writes them like that. Okay? See? And he says, now what I'm going to do is I'm going to add all these numbers together, but I'm going to do it like this. What's 1 plus 100? You tell me.
101.
Say it louder, they can't hear you.
101.
Bravo, it's 101. Now, if you add 2 plus 99, guess what it is? Say it loud.
101.
It's 101 again. And guess what happens if you do 3 plus 98? 101. And if you go over here, you got it under this side, another 101. And guess what? Another.
101.
Now, do you think you'll have all 101s in between if you actually wrote them out?
Yeah.
You know why? You just say, I'll just assume, right? Well, there's a saying about assuming that we won't give you, but let's not assume. Let's say why it really would have to be. What happens every time this number goes up by 1? It becomes what? It goes up by 1 and becomes?
A different number.
By what different number? It goes up by 1 and it changes to? So I added 1 here. And what do I do here? I will subtract 1. See, so think about it. If I add 1 and then I subtract 1, doesn't that take me right back where I started? So then you know it's going to be another 101, okay? So if I actually wrote all the numbers out from 1 to 100, how many numbers would there have been if I wrote them all? How many numbers are there from 1 to 100?
100.
100, okay. So what do you really have? All you have to do is multiply 100 times 101. See? But what's the problem? I've used every number twice. See? I've used every number twice. So when you get your answer, what do you have to do to make it right? Since I've used every number twice, it's going to be twice as big as it should be. So you have to multiply, no?
I don't know.
Okay, well think about it. My number is bigger than it should be because I've used every number twice. I want to use each number once. How can I fix my answer? You can't? Let's think about that. What if I said I'm gonna give you 10 nickels, okay? But I actually gave you 10 dimes. Have I given you too much money?
Yeah.
How much money should I have given you? 10 nickels, right? Which is how much?
A
50 cents. And how much is 10 dimes?
$1.
$1. So 50 cents is what? Half of a dollar? So if I gave you 10 dimes, I've given you too much. So you have to divide it in half. Divide by 2. That's correct. You divide by 2. Okay. And the same thing here. After you multiply 100 times 101, you have to then divide the answer by 2. And you get the right answer. So just that fast, instead of sitting there going 1 plus 2 is 3 plus 3 is 6 plus 4 is 10 and so on. Because what's going to happen with these kids trying to do it the long way, they're going to fill their slate up, right? And they're going to be not even halfway through. Then they're going to have to erase their answer and go back again, and they're going to forget what they had here, and they're going to start again, and they're going to be sitting there all day working on it. They're never going to get it. That was the teacher's plan. Get the nice nap. But now this kid's got the answer. Well, the teacher didn't get a nap. This is one of the classic formulas of mathematics, okay? So you multiply, there's a 50-50 chance to get it right, okay? You multiply 100 times 101. Now, do you know what happens when you multiply by 100? What's 3 times 100?
300.
So if I multiply 3 times 100, it becomes 300. See how it attaches 2 zeros? What if I multiply 17 times 100? 1700. So it simply attaches 2 zeros. So what if I did 101 times 100? What do I do with 101?
100 and 100.
Okay, so I attach 2 zeros. Attach what? 2 zeros, right?
Yeah.
You sure? When you multiply by 100, you simply attach
2 zeros.
2 zeros. So if I go 100 times 101, I'm going to take my 101 and I'm going to attach 2 zeros, okay? And I still have to divide that by 2. Can you do it or should I?
Huh?
Can you do, huh? Say, excuse me? Excuse me, we're on camera. Okay, here's the rule. Look at the camera. Here's the rule, Josh, okay? When we're being filmed, you have to pretend to be polite. Okay?
Okay.
Very important, okay? Got to pretend. I pretend to be polite too. When I'm on camera, I pretend to be a nice guy, okay? Always do that when someone's watching. Okay, do you know how to divide that by 2 or not really? Never learned that? Okay, so what's half of...
Oh, wait.
I'll let you do it, okay? Divide it by 2 and see if you can get it. There you go.
Can I just do this on my...
Oh no, wait a minute.
We're in the 1700s. You don't have a
Yeah, you're in the
calculator.
1700s. Watch, okay. 101. Let's work together.
Drop your phone.
Yeah, leave the phone. Come on.
We're in the 1700s.
Well, the problem is how the pin's not working. Okay, so what's the answer? 5,050. 5,050. Right, so the answer is 5,050. That's the correct answer is 5,050 to this problem, okay? Now, if you know the rule, you're just going to do 1 plus 100 is 101 times 100 and divide by 2. You can do it fast, okay? No teacher will ever get their nap, okay? So let's see if we can make a prediction here. What if I said I'm going to add all the numbers from 1 to 50? Okay. Can you predict what you might do?
50 times...
Yeah, because if you roll, okay, let's do it down here, okay? From I would do 1 plus 2 all the way up to 50. Then I would write them backwards, remember? 50 plus 49 all the way down to 1. And let's add them up. What do you get? 51. 2 plus 49.
51.
You get all 51s. So if I go from 1 to 50, I'd have 50, how many of them? I'd have 50 numbers.
So you just... How you get your answers just by adding 1?
Yeah, so I do 50 times 51 and I divide by 2. What if I took all, let's speak of, what if I took all the numbers from 1 to 200? Do you know how you might do that one? That's predict without even just jump to it.
200.
Time.
201.
And then
Divided by 2.
200 times 201 divided by 2. Now can we make it pretend like we can make a symbol that could be any number? Because now we have a rule, okay? So let's say we could stop at any number. Do you ever use a letter for a number or no?
And
Yeah.
You can do that? Okay, or let's make a symbol. Okay, so let's say that I go at all the numbers from 1 up to star. What would I make the rule? Show how the rule would look. Star times.
Star.
Time.
101.
Not 101.
star plus 1.
Yeah.
Star times star plus 1. Put in parentheses. And then divide by 2. And that's the famous rule. Now, this kid was 11 years old when he came up with that rule. That is a classic rule of mathematics to this day. Okay, taught in numbers. And actually, when they show the rule, they don't use star, they use n. So instead of putting a star, let's do an n. The rule goes like this: n times n plus 1 over 2. Okay? It's a classic rule of mathematics developed by a little 11-year-old simply because the teacher wanted to take a nap. So that is our little number theory video for today. So let's tell everybody thank you for watching.
Thank you for watching.
Thank you for watching, and we appreciate Joshley's input here. Did you learn anything?
Yeah. No. Yeah.
Yes or no?
Yes.
Are you gonna remember it sometime? You
Yeah.
can practice it. You remember? I'll show you how you can extend it next time. Okay. Okay. Thank you all.
Thank you.
Bye bye. Bye bye.